Hello everyone, and welcome to this demonstration video of simulation of process equipment using Aspen Hysys. Friends, in this video I am going to simulate one design of propylene glycol process using Aspen Hysys. I am Dr. Santosh Walke, currently working in Oman and practicing Aspen Hysys from last 10 years. So let us start our simulation. In this simulation, the design of propylene glycol process using Aspen Hysys will be shown. The case is in a propylene glycol production plant, we have propylene oxide. When combined with the water, the propylene glycol is produced in a continuous state tank reactor. The propylene oxide and water feed streams are combined in a mixer. The combined feed stream are fed to the reactor, which is operating at atmospheric pressure, in which propylene glycol is produced. The reaction between water and propylene oxide to produce propylene glycol is water and propylene oxide combines to give propylene glycol. Now this is a figure in which propylene oxide is one stream and water is another stream. They are mixed in a mixer, and then we are using the CSTR to produce the propylene glycol. In this CSTR we are getting the two output, one is CSTR vent and CSTR product. Here we are getting the propylene oxide in the liquid stage. So let us start simulation by using Aspen Hysys. In the Aspen Hysys, when you open, select the new case. Now there are three components in this process. So first select the component list. Very first component is a water. Second component is propylene oxide. While selection, you type it the continuous word, so propylene oxide will appear. Select. Then third component is propylene glycol. So this is called as 12-C3 diol. Now you can see we have selected the three components which are involved in our process. Second one, we have to select the fluid package. Fluid package, in this case we are going to select UniQuack. So select the UniQuack fluid package, and the reaction is going to be taking place in this process. So click on the reaction tab and you have to select the reaction. So click on add and then click on add reaction. Now there are 5 types of reactions are taking place in the Aspen Hysys. So the reaction of propylene oxide and water is a kinetic reaction. So select the kinetic reaction, click on add reaction, and you have to close this window. Now the reaction is an active reaction, that is RxN1. So now we have to give the stoichiometric information about this reaction. So double click on this RxN1. Now we have to select the three component. First one is a water reacts with propylene oxide to produce propylene glycol. So in this case, water and propylene oxide, these are the reactant, and propylene glycol is a product. So the stoichiometric coefficient for the reactant is always -1, because reactants are getting consumed and propylene glycol is a product, so it is +1. Now the rate controlling basis for this is partial pressure, and the base component is propylene oxide, and the reaction phase we are considering combined liquid. Now the value of the forward reaction, the capital A, is we are going to select 1.65 10 to the power 13. So we are expressing 10 to the power 13 by just mentioning E. So 1.65 E 13, that means 1.65 into 10 to the power 13, and the capital E value is 32000, that is 32,000 kilojoules per kg mole. Click enter. Now our reaction is ready. Close this window, and now you have to add the fluid package to this reaction. So click on add FP and then add set to the fluid package. Now the reaction is ready. Now we'll enter the simulation environment. Now click on the simulation environment, and here you have to select the two material stream. One is for propylene oxide and another is for water. So just drag the two blue arrows for material stream, red arrows for energy stream. Now we'll double click on this first material stream arrow, we have to give the stream name as propylene oxide. The temperature of the stream is 85°F. Then pressure is 1.5 atmosphere, and the molar flow of this propylene oxide is 150. The unit is pound mole per hour, so lb mole per hour, and we have to enter the composition. So there are either you can click on here or just molar flow, double click. Now this is a mole fraction, so this is the propylene oxide stream, so water will be not present, so it is 0. Propylene oxide is present in the stream 1, and there is no propylene glycol, so we'll enter 0. Click normalize and press OK. Now this color is changed, so this stream is complete. Now double click on the second material stream. Now this is the water stream. The temperature of this water is 75°F. The pressure is 16 psi. We have taken the different units of pressure. Earlier propylene oxide in atmosphere, and water is in psi. Flow rate is 12,500 pound per hour. So the unit is pound per hour. We have selected pound per hour. Let me select this unit. Pound per hour, this. Okay, and you can select the composition. Now here water is 1, propylene oxide 0, and propylene glycol is also 0. Click OK. Now it is showing some error, that means our flow rate is not right, so we will select here flow rate. Instead of pound per hour, we will select pound mole per hour. Select pound mole per hour, and then click on active, because once we change any parameter it goes to on hold. So that stream is now, you have to click it on the active, and you can see the stream is complete. So these two streams are complete, propylene oxide and water. Now we have to mix these two streams in the mixer. So in this palette window you can see this is the mixer, so just drag the mixer and double click on the mixer. Now there are two streams, water and propylene oxide. You can give the name of this stream is mixer, and the outlet stream you can give the name as mixed feed. Click OK. Now these two streams are created. Now we have to select the continuous state tank reactor. So in the object palette window you can find out this is the continuous state tank reactor. Drag it and place it over here. Now the inlet is a mixed stream. You can give the name CSTR. Now there are two outlets. First is CSTR vent, and at the bottom we are getting CSTR product. Energy you can select as a coolant. Now message is giving that reactor it requires the reaction set, so click on the reaction, select the set 1, and we have to enter the parameters about the duty. Select the duty 100 kilojoules per hour. Now it is asking the volume is not specified, so we have to mention the volume of the reactor. So you can click on the dynamics and select the volume of the reactor 250 feet cube, and here the liquid volume percent we can consider as 80%. Now you can see the simulation is complete. We'll just organize this flow sheet just by clicking the auto position all. Now we'll see what are the results we are getting. So we'll first minimize this, then right click from the mouse, select the material stream table, then add workbook table, select the composition. So you can see the composition: propylene oxide, water, mixed feed, then CSTR vent and CSTR product. Now double click on the reactor. You can click on the dynamics, and you can also able to view the strip charts. So for the small steady state you can view the strip chart, you can display it. Since this is a dynamic operations, so it is not started, we have to see it in another window. In the worksheet also you can see the composition of the stream. Initially in the mixed feed, propylene oxide is propylene glycol is not present. Then in the product we are getting the water 0.9880, and in the vent we are getting 0.9997. The oxide, propylene oxide, is completely reacted, and here in the CSTR product we are getting the propylene glycol 0.0120. Now you can see in the product the composition is very less, so you can change the composition. Now here the water we are lacking very high quantity, you can decrease the water, you can increase the flow rate of the propylene oxide, so that you can find out more and more propylene glycol can be produced. So in this way you can change the input and you can find out how much propylene glycol is produced, because here initially we have taken very small quantity of propylene oxide, that is 150 pound mole per hour, and here the water is 12,500 pound mole per hour. So there is too much difference, that is why we are getting propylene glycol very less amount. So you can carry out the experiment. Instead of CSTR you can use the plug flow reactor, and you can study the same reaction how we are getting the propylene glycol. So this is all about the production of propylene glycol from propylene oxide and water. Hope you like this window, and if any questions or any comments, please write it in the comment box. Thank you very much, and see you soon.